Hello everyone. Now we will derive equation for indicated work for a single acting compressor without clearance. So what we are going to derive is we will derive the equation for indicated work for single acting compressor for single acting compressor without clearance. Without clearance. So what is the single acting cylinder? To say the single acting cylinder is one where this is the piston cylinder and this is the piston, this is piston rod. So in case of single acting cylinder, the air is taken in, the compressed air is left out in only one side. So other side of the piston will not do any work. In case of double acting, there is a allowance where the valves are present that will also execute the suction and compression work when the piston moves from right side to left side and when it moves from left to right. So when during first stroke from side R to L, the air which is present in this region gets compressed and it will be delivered out to the delivery tank, and in the movement from left to right, the air which is present behind this piston will get compressed and it will be delivered to the tank. So but now we will derive for simplicity. We'll first start with the derivation for the single acting, only one side, and the compression will be taking place, and there will not be any clearance, so that means the piston will exactly reach this end. So for this case we can draw a PV diagram. We'll draw a PV diagram for this case. The PV diagram will be like this: y-axis pressure, x-axis volume. This is pressure, this is volume. So this is PV diagram, and the compression will be taking place in this way. First suction, then it will be compressed to pressure from P1 to pressure P2. After compression, for the same pressure it will be delivered to the tank. Atmospheric air is taken in and it will be delivered to the tank. So now this has three regions. This has three regions, and the area under this curve represents the work done by the compressor. So the area under this curve represents the work done by the compressor in the PV diagram. So that is why we need to that is how we can find the indicated work. So what we have to do now, we have to first mark these points. Let us mark this as 0 and this point as say V1 and this point as say V2, and then we will mark this as 1, 2 and then we can mark this as D, this one, this point. I will redraw this one more time. So in this figure we can name this as, this is starting point O, then this is A, this will be considered as B, and this can be written as C, and now this will be marked as D. So each has a different area that you should know, and now here we will we know this is V1, this is V2, this C and are P1 and P2, and this is the compression process. This is the compression process, and this point is 1, this point is 2, and this is suction, this is delivery. So now we have 3 different areas. One is this region OB2D, then we have AB21, this is second region, and next we have this one 1AOC. So these are the 3 different regions that we should remember, and I will explain what are these things now. So now we see the indicated work is nothing but area of this region from this C1 to D. So this is the actual work done by the compressor, that is indicated work. That is what we have to find out. So the indicated work area C1 to DC, C1 to DC is of is the area of our interest, and to get this we have options. Like what we can do is, this area is equal to, we can add this area plus this area is area say 2DODB2. So area 2DOB2 plus area, the second area what we can see is this one. So this area is 1 2 B A 1. So this area plus this area minus, so we have to subtract this area. So if we subtract this area, then the area what we get is the work done, minus area 1C 1CO A1 1COA1. So this is subtraction. So if we substitute the equations, we will get the work done for this region, and that is the indicated work by the compressor. So here these two areas, area this one and area this one, can be obtained as P1 V1 and P2 V2. These areas can be written as P1 V1 and P2 V2. So this I will take it as this is P1, right? P1 V1, P1 V1 and P2 V2. So what I will write here is, this is P2 V2, this is equal to P1 V1. Here this area is a polytropic work, that is 1 2. So from work done from 1 to 2 can be obtained by, that is a piston displacement work in terms of polytropic process. It is given as minus integration of P into dV. So now the work in process 1 to 2, the work in process 1 to 2 is it's a PV power gamma is equal to C, not gamma, actually it is N. So it's a PV power N is equal to C. So in that case, work done is equal to integration of P dV, which is P2 V2 minus P1 V1 divided by N minus 1. And therefore, so total work done can be written as P2 V2 plus P2 V2 minus P1 V1 by N minus 1, that minus P1 V1. So this is one important step you should remember. Later in the next step we'll just modify this. We'll just modify this equation. It can be written as, we'll take P2 V2 minus P1 V1, P2 V2 minus P1 V1, that we'll take it as common. So we'll take this here, we'll take it common as outside, then it becomes 1 plus 1 by n minus 1. So this is what we have taken out as a common. So this can be written as W in, this is input power n by n minus 1 into P2 V2 minus P1 V1. So this is after modification of this 1 plus 1 by n minus 1. So this is an important step. So we got W equation. In this equation, the work output what we get will be in terms of kilojoules, but very important thing we should know is this is per cycle. This is per cycle. So the unit is kilojoule per cycle. So in later onwards, while solving problem, we will get so many values. So we should know whether that is given in terms of kilojoule means kilojoule per second or kilojoule per cycle. So that difference is very important. Now we will rearrange this equation. What we can do is we will use one gas equation, that is we can write this in terms of temperature using P is equal to PV is equal to MRT. So using this equation, PV is equal to MRT, mass of air into R into T, gas constant into temperature in terms of absolute scale. So W is equal to, as usual, same n by n minus 1. I'll just try to make a notation in this form, into n by n minus 1 into n by n minus 1 into we will substitute MAR into T2 minus T1. We will get this in terms of T2 minus T1. Then again this is also in terms of kilojoule per cycle. Next, what we can do is we can take out T out. So this becomes W is equal to n by n minus 1 MRT1 T2 by T1 minus T1, and that T2 by T1 is pressure ratio, but we know that, so already we know that T2 by T1 is equal to P2 by P1 power n minus 1 by n. P2 by P1 power n minus 1 by n. So with the substitution, we will write the final equation. We will write the final equation. So the final equation is W is equal to n by n minus 1 This triangle shape you should remember, so that you will not confuse whether it is n minus 1 by n or n by n minus 1. There may be a few cases you might misuse it or wrongly substitute and do the calculation. So mrt1 into p2 by p1 power, this is reverse, n minus 1 by n, n minus 1 by n minus 1 kilojoule per cycle. And similarly, another equation can be W is equal to n by n minus 1 P1 V1 times P2 by P1 n minus 1 by n minus 1 kilojoule per cycle. So these are the two important equations that you have to remember, and it will be useful for solving the problems. This is again n minus 1 by n, same thing. I have not drawn this triangle, just for your reference, that's all. You can refer textbook available for further details.